Graham's law of diffusion. Okay. Let us know first the difference between diffusion and effusion. Diffusion is the process by which gas particles move, in which two or more gases mix spontaneously until they form a uniform mixture. So example is spraying perfume of your body spray, then the gas or from your perfume will mix to the air, and we know that air is mostly a gas. Diffusion is a process by which gas molecules pass through a very small opening from a container at higher pressure to one at a lower pressure. Example is the loss of gas inside of a balloon over time. Graham's law of diffusion is same with Graham's law of diffusion relates at which molecules move to their molar masses. Diffusion and diffusion are similar in terms of rates and speeds. The rate of diffusion is inversely related to the square root of the molar mass of a gas. So we have rate A over rate B is equal to the square root of molar mass B over molar mass A, where mm is the molar mass and rate is the speed of the molecules. Remember that the heavy gas moves slower than lighter gases, so meaning if the molar mass increases, the rate of speed of molecules decreases. Example, how fast is the rate of diffusion of H2 compared to that of O2? So solution, the molar mass of H2 is 2 grams and that of O2 is 32 grams. Actually, the molar mass of oxygen is 16, and since we have 2 here, so 16 times 2, that is 32 grams. So based from your periodic table of elements. Following the equation, we have rate of H2 over rate O2 is equal to the square root of 32 grams over 2 grams. Remember, always put the lighter one on top. Always put the lighter rate on top. So we have here 32 divided by 2, that is equal to square root of 16. And square root of 16 is equal to 4. So therefore, hydrogen effuses 4 times faster than oxygen.
Okay, for our second example, we have the rate of diffusion of argon was measured to be 0.218 molecules at a certain temperature. Calculate the area of diffusion for helium gas. So we have 0.218 as the rate of our argon, and we're looking for the rate of helium. And to locate our molar mass or the molar mass of argon and helium, so let us going to locate it in our periodic table of elements. So we have 40 for the molar mass of argon and 4 for the molar mass of helium. So we have rate of helium over 0.218, which is the rate of argon, and is equal to square root of 40, which is the molar mass of argon, over the molar mass of helium, which is 4. So why I put the rate of helium here on top? Because always remember to put the lighter one on top, or the rate of the lighter gas on top here. And the molar mass here, class, indicates that argon is the heavy gas compared to helium, okay, for this example, because as gas increases, the rate of the gas decreasing, okay. So let us divide 40 by 4, that is 10, or square root of 10 is 3.16. Okay, because we're looking for rate of helium, so we're going to multiply both sides by 0.218, so that will cancel here. So we have rate of helium over, our rate of helium is equal to 3.16 times 0.218 is 0.69. Therefore, our final answer is 0.69. Okay, for our third example, compare the rate of diffusion of nitrogen gas to helium gas. How much faster does helium travel than N2 or nitrogen 2. So for our solution, the molar mass of nitrogen is 14 times 2 because we have 2 here. That indicates that we're going to multiply 14 by 2, that there are 2 nitrogen. Okay, so equals 28 grams. Molar mass of helium is 4. This molar mass class, or guys, is from your periodic table of elements. And of course, we already know that the lighter gas travels faster. So we already know that helium travels faster compared to nitrogen. But let's calculate how much faster. So we have rate of helium over rate of nitrogen is equal to square root of 28 grams over 4 grams, which is the molar masses of our gas. So we put rate of helium here again because this is the lighter one. The helium here, the molar mass of our helium is lighter compared to the molar mass of nitrogen. So we have 28 divided by 4. So it is 7, and square root of 7 is equal to 2.65. So therefore, helium diffuses faster or traveling 2.65 times faster than nitrogen 2. For our fourth example, we have an unknown gas has a rate of effusion that is 4 times faster than oxygen gas O2. So calculate the molar mass of unknown gas and determine the identity of this gas. Okay, so we have rate of unknown gas over rate of oxygen is equal to the square root of molar mass of oxygen over rate of the unknown gas. So why I put the unknown gas here on top? Because the statement tells us that the rate of effusion of unknown gas is 4 times faster than the oxygen. So therefore, the unknown gas is faster than the oxygen. So that means that the unknown gas has a lighter weight compared to the oxygen. Okay, so oxygen, or the molar mass of oxygen, is 16, and we're going to times it by 2, so that is 32. So if ever class, if the rate of oxygen is 1, so that means the rate for unknown gas is 4. And if the rate for oxygen is 2, that means the rate for unknown gas is 8. So if ever the rate for oxygen is 3, then the rate for unknown gas is 12. As long in whichever no among these rates we're going to use, it doesn't matter as long as they agreed to each other. Okay, they agreed with the statement 4 times faster than the oxygen. So for now, we're going to use this one. Okay, rate of oxygen is 1 and the rate of unknown gas is 4. Okay, so we have 4 over 1 is equal to the square root of 32 over x. And we are looking for the molar mass of the unknown gas. And then we're going to determine it later. So we have, so to eliminate or to get the x here, because we're looking for x, so we are going to square both sides. Okay, so squaring both sides, that means if there is just a single square class inside the parentheses, that means that we're going to cancel out the square or the radical here, or the square here, or in other words, the square of square root is the number inside the square root. Again, the square of square root is inside the number of the square root. Okay, so that means we have 4 squared is 16, and the square of the square root is 32 over x. Okay, the square of the square root is a number inside the square root. Okay, so let's multiply both sides by x. Okay, so we have 16x is equal to 32. Then we're going to divide both sides by 16 because we are looking for x. So that is division property of equality class. So that means x is equal to 32 divided 16. That is equal to 2. So that means our molar mass of the unknown gas is 2, and therefore it is hydrogen. Okay, hydrogen H2, or the molar mass for hydrogen is 1 times 2.